The problem would be if one thread calls send on the size buffer, then another thread comes in and calls send on the size buffer, and the other thread comes back in and calls send on the bytes, and then another thread comes in and calls send on the size buffer. Then on the server side, everything's going to get all conjoined and all screwed up. So this is where the thread synchronization would come into play. We would take that same code, and then we would do this. What this simple thing does is it will call the lock on this object so nothing else can touch it. Only thing that's allowed to execute if this line of code is called is inside of this stop right here. So if 5 threads decide to call this, only one thread can do this to make sure the data is still aligned. Then another thread locks the same object, does its thing, and so forth, and so forth. So there are a couple of different ways that you can send off information. During our tutorial, we might end up just doing this. Since our size buffers are not going to be that big at all, we're going to make sure we keep things compact and fast. At least in our applications. I mean, we could send as large of a file as, as large of data as we want, but it'll be better to keep things small and compact so nothing's choking up and there are no bottlenecks, so we can keep bouncing back and forth. So most likely this is going to be the example that we're going to use, or we may use this too. Since we might be doing rapid sending, so this will be the best thing for that. I'll need to check and see if .NET still has a memory leak with begin send, but like I mentioned before, a lot of information does not end well. What we could do also is have a send method and then a send rapid method. So if you know you're sending information like this, and it's just back-to-back non-stop, we would use this. If not, then we would use this. Sound good? Sounds pretty good to me. And we handle the receiving? Oh yes. Now that we got the sending, now let's go back over to receiving. And also, the server and client are going to use the same exact class. So whatever we edit in here, we're going to be doing both sides in one class, I should say. Because once we accept the client in the TCP listener, we're going to wrap it up into this. And when we connect on the client side, we're also going to wrap it up into this. We write it once, we use it on both sides. Now, getting back to read, this is where we need to make sure the information is lined up and make sure we receive at least the same amount of information, since we won't actually know unless we receive it and then we maybe use a checksum or something. But we're going to do a more simpler version of this for now. So after we read our buffer, and we're just going to do this sync. Since we're expecting more data to come in, we're expecting data to come in right after that, we can just do this synced, or we can do this actually, no. We're not going to do this part sync. We're going to do everything. Who hit something? Anyway. We're actually going to do everything async. So just forget what I just said. Now we're going to expect to receive 4 bytes. With the initial send, with the initial receive, we're expecting 4 bytes. So we're going to check red. If red is less than, it's not 4 bytes, is less than 4, which is going to be our size buffer. As a matter of fact, let me go ahead and put this up here. The size of an integer, a 32-bit integer, is 4 bytes. And that's going to be what we'll use as our size buffer. So our size buffer length will be 4 bytes. if red is less than the size buffer length, this is what we're going to do sync. Because if the read buffer gets split up, we should expect to catch up within the next second or so. So it really doesn't make much sense to call begin receive again when we know it's coming right after that. So if the size buffer is, if red is less than the size buffer length, then what we're going to do is call receive again. So what we're going to do is call while true and do int expected equals size buffer length minus the amount of data that was read. So if we were expecting 4 bytes and only 2 bytes came through, we're expecting 2 more bytes. So while this.s.available is less than expected, then we'll just call thread.sleep for like 10 milliseconds or so, just so we're not destroying the CPU. Once we know that the rest of the data is there, or so we think, something could have gotten screwed up along the way, but this is what we're expecting. This.s.receive our buffer red and buffer red and expected and 0. So what we're doing here is we are still writing to our same buffer. We're going to continue writing where the original receive or begin receive should have ended, but it didn't because some data got split up. And then we will write with the length that was expected. So if all the data came through together, if say 10 bytes were sent, 2 bytes popped up first, but then the other 8 decided to come together, we're not going to read the other 8. We're only going to read what should be expected from the size header. And after we do that, if that happens, all the data might come through together, the size buffer might come through together, it all depends. But if that does happen, then we have our little catch right here, just in case. But then after that, we're going to go ahead and receive the rest of our information. So we're going to have another callback. Private void read. We're going to read our payload. Read payload callback async results AR. Yes, this is how lazy I am. Okay. So now after we have our buffer size that we're expecting to receive, we need to store this somewhere. We could just pass it into the state object so we don't have to actually deal with that, which, actually, sure, let's do that. If int payload size equals bit converter dot to int 32 buffer 0. So we're going to use our receive buffer as the input for the bit converter to convert it to an int 32, and the position we want it to read from is 0, the beginning of the file. This will only read 4 bytes. Since int32 is only 4 bytes long, it's only going to read the first 4 bytes of this buffer. And once we have our payload size, now we're going to receive the actual data. So this.s.begin receive. We're going to still use our buffer 0. Receive as much as we can. The callback is going to be our read payload callback, and then our payload size. We will pass our payload size in. You could also make this a global variable, but let's just do this a different way. Payload remaining, we'll grab this from our state, we'll cast it to an integer, ar.async state, and then int red equals, I'll stop train of thought for a second, this dot s dot end receive ar, and now we're going to have payload remaining minus equals the amount of data that we just read. And there's one thing that I forgot about, and that is the memory stream to handle the saving of the payload. So for this, you could use a buffer, a byte array, but it's easier to use memory stream. There's no point in manually manipulating the data. Memory stream payload stream equals nothing. Nothing right now. Once we receive our size, then we'll create it. Let's do this after we get the payload size. Payload stream with new memory stream. This is what's going to hold the full payload, and then we'll pass it on to our received payload event. We didn't code that yet, but that's something that we can use after we receive all of the information. So we read how much data we received, we negate that from our current remaining payload, and then we'll write it to our payload stream, buffer 0, and the amount of data that was read. If payload remaining is greater than 0, that means we just got to keep on reading. Just keep on going until we receive everything. And then use payload remaining instead of payload size as the state. If not, then we're good to go. Call begin read, and then we'll have to invoke our event, which we'll go ahead and add just for pseudo purposes. Public event handler, TCP Socket received event args. Just call it received. And then we'll call received this texting. That's a good thing. I was not expecting that to go off. Okay. Now this, and then we would do the use a constructor for our forgot the name of it. Stupid bananas. Knocked the thought right out of my head. That was it. TCP Socket received event args. This will be our class that we would make, and then we will pass the payload stream dot to array after we close it. Payload stream dot close. We call our received event, and then we will call begin read to begin reading the size. Not begin read. Yeah, begin reading the size buffer to receive more information. So from what I've seen here, this is essentially what I would do to wrap this up in order to turn it into something that's usable. One other thing, whenever we have an issue with this, we're just going to go ahead and call our disconnected event, which would be this, and then event args.empty. An exception which should not happen, we'll just call or tell the socket to disconnect. Same thing in our send methods, we have our try catch. And if something screws up with send, then we'll just go ahead and disconnect the client. Because once the data stream is all screwed up, just let it go. Let it go and reconnect. Unless you just send a bunch of null bytes to clear out the stream and then go on from there. But in closing, based on what we analyzed and what we read here, this is a way that we could create a reusable listener and socket wrapper for handling input and output, disconnection, all that good stuff. And in the development video, we're actually gonna take this, we're gonna test it in a environment similar to this, and then after we test it, after we make sure everything is working and grand, then we're gonna take what we made here and use it in a chat application inside of Windows Forms that is leaning more towards an actual real-world application. Hope you guys learned something from this video, and I'll see you in development. Now it's going to get fun.